Well, hey everybody, and welcome to this Wednesday edition of the Weather Academy, and happy Earth Day. Today is Earth Day, so hopefully you'll be able to spend some time outside and enjoy our planet today. We're getting a nice break in the weather. Its temperatures are pretty warm across the area. It's a nice afternoon, so I hope you're able to at least get out in the yard and enjoy it. Maybe plant something today in celebration of Earth Day. We're going to talk about thunderstorms today. So that's a big topic all the time. We talked about lightning a couple of weeks ago. So we're going to talk about thunderstorms a little more detailed. There's actually four kinds of thunderstorms that we'll be talking about today. Some of them produce severe weather, some of them don't, but we're going to start it off with our little video. So there you go. All thunderstorms produce lightning, and that's probably the biggest thing that you need to know is you have to have lightning in order to create thunder, and so that's basically the get-go from the beginning here of where we start. Now, what causes thunderstorms? Well, typically on a hot, humid day in the summertime, you get the warming of the day, the sun comes out, kind of like today, it's heating things up. If you have enough moisture around, you'll start to see some of that air rising as the ground heats up, the air rises, and we'll start to build some clouds. And from those clouds, if there's enough motion to carry it up, then you end up dealing with thunderstorms. So that's our topic today. And basically, if you hear thunder, you've observed a thunderstorm. And also, if you hear thunder, um, you're close enough to be struck by lightning. So you want to be inside during a thunderstorm. That's the safest place to be. And you're also safe in a car. All thunderstorms contain lightning, and lightning causes thunder when it heats up the air. Okay, lightning is dangerous. Let's get that out of the way right away. Look at this lightning strike here from the National Weather Service. That's taken on that tree right now. And lightning is really nothing more than a spark of static electricity. So, all of us have experienced static electricity, especially when we have these dry days. Even today, you could have a little bit of static electricity because the air is so dry. And all thunderstorms contain lightning. Now, we talked about clouds last week, and thunderstorm clouds are called cumulonimbus clouds. They're the ones that billow up into the sky. They grow high. Sometimes they can get as high as 5 miles up into the sky. So that's pretty impressive, right? That's a big, tall thunderstorm. Now, here's the different types of thunderstorms, and it all has to do with the winds that are happening in the atmosphere, not just close to the earth, but going up through the different layers of the atmosphere. And remember, we talked about the layers of the atmosphere last Friday, I think it was. So you have the single cell thunderstorm. That's your kind of typical run-of-the-mill thunderstorm. We have multi-cell thunderstorms. You see that picture. The supercell thunderstorms, which almost always produce severe weather, and they are also some of the most spectacular to see. And then you have the squall line. So what makes a thunderstorm severe? Well, there's really only three criteria. You don't have to have a lot of rain. In fact, some thunderstorms, especially out west, are based so high because the air is drier that actually they never do produce any rain, but they do produce the lightning. But in order to make a storm severe, you have to have one of three things. The winds gusting to 58 miles per hour or greater, hail to the size of a quarter in diameter, which is 1 inch, and that's when the hail starts causing damage. That's when it can start dinging your car up and causing problems. Or the thunderstorm produces a tornado. So it's damaging winds, large hail, or a tornado. That's all that makes a thunderstorm severe. The amount of lightning in a thunderstorm, while it can be pretty significant, you can have an impressive lightning storm, and yet it's not severe. It can be a drenching rain. You could get an inch of rain, maybe in a half an hour, even faster than that, and it's not severe. Now that causes some flooding problems potentially, and that's a whole nother issue, but that's not severe. It's only three things that make a thunderstorm severe. But during any thunderstorm, you should be inside and in your safe place. We don't want to be outside during thunderstorms. So damaging winds, large hail, tornadoes, they make thunderstorms severe. So let's talk about this single cell thunderstorm. This is what we call the garden variety thunderstorms. And this is typical of the summertime. During the afternoon, the early evening, when you've heated things up and it's basically, the warmest part of the day, if there's enough humidity and if those winds, we call them parcels. Think of it as like a bubble of air that gets heated up and starts rising, and eventually it can create a cloud, and then that cloud can grow into a shower or thunderstorm, and then it eventually falls apart. And the reason it falls apart, this typical thunderstorm situation here with a single cell, if you just look across these three pictures, once it gets into the mature stage where it's actually starting to produce heavy rainfall and maybe even some small hail, what happens is that rain starts dragging the air down out of the clouds, and so then it kills the updraft, which is driving the thunderstorm, and the storm goes away. So usually it gets a brief heavy rain, maybe some small hail, and a few wind gusts. Very rarely are these storms severe storms, but they have lightning in them, so you need to be safe and you need to be inside. Multiple cell thunderstorms, they're more likely to produce severe weather, and the storms continue to develop because if you look at this, you've got the strong right in the middle, the mature thunderstorm, and then it's kind of dying off on the right side, but you're already looking at additional thunderstorms developing back to the west. There's more air rising. There's more thunderstorms developing. So these tend to be a little more likely to produce severe weather because they can keep going and they keep regenerating. So sometimes they do produce strong winds, hail, maybe even a brief tornado if the winds are just right, and you can get some rotation in those storms. And they also produce heavy rain that can cause flash flooding because a lot of times when you get these multiple cell thunderstorms, what's happening is you get the storm and it dumps a lot of rain, and then the storm that's building behind it kind of rolls right in where you are again, and you get more rain, and it just keeps coming. We call those training thunderstorms. And so you can get a lot of rain over the same area as those thunderstorms roll on through. And so that can cause flash flooding, and that, of course, can become another problem that we have to deal with. And we'll talk about flooding and flash flooding more in depth in the weeks to come. Now, our next line of thunderstorms, or the next type of thunderstorms, a squall line. This is what it looks like on the radar. It's basically a line of stronger thunderstorms. Usually they're moving pretty quickly. Okay, so they don't hang around. So you don't really have to worry about flash flooding. They'll produce heavy rain, but it just doesn't last very long. They do produce severe weather sometimes, strong winds, hail, and depending on how they evolve along this line, we can get brief tornadoes that drop out of those thunderstorms too. But they're usually real quick hitting, and they're not necessarily as strong as what you might get from this type of storm. This is a supercell thunderstorm, and they almost always produce severe weather. You're looking at that wall cloud. That's the lowering part of the cloud right now. And if you look at a supercell thunderstorm, actually kind of get the whole schematic of it, it almost looks like a mushroom cloud. These are the huge storms. And when it's a supercell storm, it's basically its own weather system, if you will. Okay, so it's its own storm. So it's hogging all the moisture, it's using all the energy, and it's got a lot of complicated winds in it. So if you look at this storm, you see that lowering part there in the back of the thunderstorm cloud. That's where the wall cloud is, and that's where the best rotation is. And that's usually, if you're going to get a tornado, that's usually where you'll find it. So this is the cumulonimbus bubbling up. And just how far does it bubble up? Well, look at the top in the middle there. See that little cloud kind of shooting over the top? That's where the air is rising so fast, it's actually breaking through kind of the top of the lowest part of the atmosphere, okay? And so when you get those clouds, and actually we're going to look at a satellite picture here in a minute, and you'll see some of those from space, what they look like, because it's happening right now down to our south. So ahead of this storm, on the front side of it, you have the rain and probably some hail in there. And then once that lets up, then you get into the tornado and the wall cloud. So if you look inside this cloud, look at all the wind that's going on in here. So there's a lot of winds, and many times they're coming at different directions, especially as you look down to the surface. You're usually getting the winds feeding this thing from maybe the south or the southeast. And then as you go up through the layers of the atmosphere and up into the tops of the clouds, not only do you have strong winds that are ongoing, they get stronger as you go up higher in the clouds. That's wind shear. That's actually speed wind shear because the winds are increasing as you go up. But you also have something called the directional wind shear. The wind is twisting. It's turning as it's going up. And so that creates the twisting in the wind. And the whole thunderstorm itself is literally a rotating thunderstorm. It's like its own little weather machine. And the whole thing is rotating. And when you can get that rotation to tighten up and get closer to the ground, that's when you can find your tornadoes that touch down from those storms. Here's a picture of one of those supercell storms. This is actually from the National Severe Storms Laboratory. They have a portable Doppler radar, Doppler on wheels, the Dow, and they actually, that's what you see, those lights there on the right on the road. They're actually scanning with the radar. They're in a safe place. They know where the storm is and they know how it's moving, so they're in a safe place, but they're scanning up close to look inside the storm to see what the winds are doing, to see where the hail is, to see where the rain is, and how it's all moving and twisting in the storms so that they can learn more about it. So that brings us back to our four different types of thunderstorms: the single cell, the multi-cell, the supercell, and the squall lines. During the summertime, you're going to get those single cell storms around St. Louis. They're going to pop up during the afternoon. They usually don't last very long. So that's the typical run of the mill. You still want to be inside because they contain lightning, and lightning, of course, as we all know, is very dangerous. It heats the air up to about 50,000 degrees, and that quick movement of the air, because it just got heated up so fast, is what causes the thunder. So those are the typical afternoon, evening thunderstorms that we deal with. Then you have the ones that are multi-clusters that kind of just keep fueling each other and they keep going. We see those a lot, especially when we get the right conditions and a weather system is coming through. We talked about high and low pressure. We talked about fronts. A lot of times you can see that. And a lot of times along the front, you'll get a squall line, and that'll have the big long line of thunderstorms out ahead of that front that sometimes produces severe weather. And a lot of times that produces damaging winds with those thunderstorms. And then, of course, the supercell thunderstorms, which are the most impressive of all. Those supercell thunderstorms, kind of their own little weather machine, kind of creating their own weather. They take all the available moisture, and that's why they're so dangerous. They take all the moisture, they have all the ingredients, and they can sustain themselves for hours at a time. Now, let me see if I can find here. I believe I've got it. Here is what's going on the visible satellite imagery right now. This is from the College of DuPage, and this is actually happening right now. And from the satellite, I've added, you see all those little blue and orange and kind of magenta colors. Those are all lightning that's detected. That's all the lightning that's detected inside these storms from the satellite, not the ground detection, but from the satellite. And if you look very closely, you can kind of see how these storms are bubbling up. This is what we call a visible satellite picture, and it's actually taking the picture of it. And so you can see those storms are kind of rolling in across Oklahoma. They've produced some hail. And then down into southern Oklahoma, there's one cell that's right. Let me get into it here for you, and I'll kind of see if you can see it there with my mouse. Kind of circling that cell down there. That is a really intense cell, and it actually has the most lightning at this point. So if I put the overlays back on here, I'm going to take the lightning off for a second, and then I'm going to go and put the radar on here. It'll take it a second to add. But there's your radar on top of the thunderstorm clouds, so you can see where the storms are. Now you see a lot of rain coming into southwest Missouri too. That's kind of more of a layered rain. It's not severe, but that's pushing towards us. So we're already starting to see the clouds increase, and we're going to see rain develop here later on today. But the best chance of severe weather is going to stay to our south, and one of the ingredients we look for that is what we call the cape. And I'll take the radar off. But this is, you see how it's much higher here as you go south of Oklahoma and into Texas. That's where the really warm, humid air is. And right now it's being lifted aloft into Oklahoma. So it's riding up into Oklahoma and producing large hail with most of those thunderstorms right now. So those are our 4 types of thunderstorms. Remember that all thunderstorms have lightning. Thunderstorms can produce, but they don't necessarily have to produce heavy rain. They can produce strong winds, but they don't necessarily have to. They can produce hail, but they don't necessarily have to. And sometimes they can produce a tornado. There's about 100,000 thunderstorms in the U.S. in a year. And we have about 50 days in the St. Louis area where we actually have thunderstorms each year, but only about 10% of those thunderstorms actually become severe. So the number that actually produce the large hail and the damaging winds, and far fewer even produce tornadoes, but just to be severe, it's about 10%. So about 10,000 a year. And that's why you get the severe thunderstorm warnings, and that's why when those storms are rotating and we can see the rotation in there and we see it tightening up and we think there's a tornado possible with those storms, that's why tornado warnings are issued by the National Weather Service in St. Louis and all across the country to keep everybody safe. So that is our program for today, our Weather Academy lesson for today on thunderstorms. Hope you enjoyed it. We're going to talk about what a watch is and what a warning is and how to stay safe during severe weather on Friday. And then next week, we're going to take our thunderstorms a step further and talk about the ones that make hail and how you make hail. And we'll see what some examples are of that as we head into next week. So that'll be a lot of fun too. All right, you guys have a great Earth Day. Still got a few hours before it starts raining in St. Louis. There's still some sun through the clouds, so get out and enjoy it on this Earth Day while you can. Thanks for joining us today.